In today's section 1.6, we're going to be talking about solving equations that involve absolute values. To do that, we have to introduce a couple of rules or facts. So, we say that given the absolute value of u is equal to c, then to solve for u, we say that u is equal to c or u is equal to negative c. We create two equations without the absolute value and solve each one of them to find the possible solutions. Now think about why this is the case. Why are we creating two equations from one and removing the absolute values? Well, there are two values that could have caused us to get c given this absolute value of u. We know that if we plug c into the absolute value function, we will get c. And if we plug negative c into the absolute value function, again we will get positive c. In both cases we get this positive c. That means we need to solve an equation where u is equal to the positive c value or the negative c value. And by solving both of these, we solve the original equation. We also need to introduce another fact, so we'll label this 1 and label the second one 2, where we say that if you're given the absolute value of u equals the absolute value of v, then the absolute values cancel out, leaving us with u equals v. But again, there's this other case where we say u can also equal negative v. And technically there are two more cases where you could say negative u equals positive v or negative u equals negative v. I'll write those off to the side. We don't include them for a reason. So we don't include negative u equals v or negative u equals negative v, because in either case, if we multiply each side of the equation by a negative 1, which will not change the problem, we'd end up getting u equals negative v, which is what we already had. And over here, if we multiply each side by a negative 1, we'd get u equals positive v, which is what we already had. So these are just repeats of these two, meaning if you have two absolute value functions equal to one another, or absolute value expressions, you can set the insides equal and then the insides with one side made negative equal. And solving these two equations, not including these two, so I'll put a dotted box around this to show it is not necessary to include this. But by just solving these two equations, you will then solve the original absolute value equation. And this is how we approach problems that involve absolute values. So, let's consider some examples. We have the example of absolute value of x plus 1 plus 3 equals 5. So solving for x, we first need to get the absolute value expression isolated, so we will subtract 3 from each side to get absolute value of x plus 1 alone equal to 2. And now we can use our first fact. Drop the absolute value to get x plus 1 alone, and that's equal to 2. Or dropping the absolute value again to get x plus 1 equals negative 2. And now we solve in both cases. We'll subtract 1 from each side on the left to get x equals positive 1, or subtracting 1 from each side on the right gives us x equals negative 3. Meaning x equals positive 1 or negative 3 is a solution to the original problem. And we can give this a quick check just to make sure these are correct. Plugging 1 back in, we'd get the absolute value. I'll make a note, we're just checking here. The absolute value of 1 plus 1 plus 3, we're checking does that equal 5. So we get the absolute value of 1 plus 1 is 2 plus 3. That does equal 5. So x equals 1 does check out. And then again, plugging negative 3 in for x, we get negative 3 plus 1 plus 3. We're checking does that equal 5. Negative 3 plus 1 is negative 2. So we have the absolute value of negative 2 plus 3. We want to see if that's equal to 5. Absolute value of negative 2 is positive 2 plus 3. We know that does equal 5. So this answer checks out as well. So both of these answers solve the original absolute value equation. Okay, so let's go ahead and try some more here. Oh, I apologize. I'm just clearing this up really quick. All right, close enough. All right, so back to another example. Now let's try the absolute value of 2x plus 7 minus 4 is equal to negative 7. Going through this, same scenario. We're going to start by isolating the absolute value. So we'll add 4 to each side, add 4 to each side. That's going to give us the absolute value of 2x plus 7 is equal to negative 3. And now at this point, you might be really tempted to say, let's set 2x plus 7 equal to 3, or 2x plus 7 equal to negative 3. But there is an issue here. Hopefully you caught it, and it's that we have the absolute value equal to a negative number. The absolute value function can never produce a negative output. The lowest output it can produce is 0, which means this scenario is impossible. There is no value that would cause 2x plus 7 to give a negative output when it's plugged into the absolute value function, which means this step is not needed. There is automatically no solution to this problem because this is less than 0. So always remember to make sure that the constant makes sense once you get the absolute value alone. It has to be at least 0. It can be 0, it can be positive, but it cannot be negative. Let's go ahead and try some more with this. Okay, so trying another example, we'll try the absolute value of x plus 4 equals the absolute value of 2x minus 5. So our rule for this says if we have two absolute values equal to one another, we are going to set what's in them equal to one another. X plus 4 equals 2x minus 5. And then we're going to set them equal to one another again, but we're going to make one side negative. It doesn't matter which side you pick. I'm just going to go ahead and stick with the right side because that's what our formula said. So we're going to make just the right side negative. Remember, don't make both sides negative though, otherwise it brings you right back to this equation you had here. You can only make one side negative to follow this process. So solving for x, we're going to subtract x from each side to get 4 equals x minus 5. We'll add 5 to each side to get x equals 9, and this side is solved for. Over here, we'll distribute the negative first to start solving for x. We'll get x plus 4 equals negative 2x plus 5, because a negative times a negative gives us a positive. Solving for x, we're going to add 2x to each side, which gives us 3x plus 4 equals 5. And then subtracting 4 from each side gives us 3x equals 1. Dividing each side by 3, we get x equals 1/3. So our solutions are x equals 1/3 and 9. And we can do a quick check to make sure these checked out. Plugging 1/3 in, we get the absolute value of 1/3 plus 4. We want to see if that's equal to the absolute value of 2 times 1/3 minus 5. Oh, sorry, I clicked the wrong button there. That is an absolute value symbol. Okay, so solving this, we get 4 plus 1/3. We have to get a common denominator, so we'll change this 4 to 4 over 1 and multiply by 3 over 3, which gives us the absolute value of 1/3 plus 12 over 3. We want to see if that's equal to the absolute value of 2/3 minus, again, we need a common denominator of 3, so this 5, we'll put it over 1, multiply by 3 over 3, and that gives us 15 over 3. So we get the absolute value of 13 over 3 when we add our numerators and keep the denominator. We're checking if that's equal to the absolute value of 2 minus 15 is negative 13 over 3. And yes, these are equal. The absolute value of a positive is equal to the absolute value of its negative if they're the same value otherwise. So this checks out. We can quickly do the same thing for 9. The absolute value of 9 plus 4, we check if that's equal to the absolute value of 2 times 9 minus 5. So we get the absolute value of 13 equals the absolute value of 18 minus 5. And yes, 13 does equal the absolute value of 13, which means both of our answers do check out. Okay, so we'll go ahead and take the time to do one more example here, just to really get our practice in. So for this last example, go ahead and take a moment and pause the video and try to solve 2x minus 3 equals 5. All right, so trying this together, we have the absolute value already isolated. It's equal to a positive number, so we can apply our formula. 2x minus 3 equals 5, or 2x minus 3 equals negative 5. Solving for x, we'll add 3 to each side, which gives us 2x equals 8. Dividing each side by 2 to get x alone, we get x equals 4. Solving the equation on the right, we'll add 3 to each side again to get 2x equals negative 2. Dividing each side by 2, we get x equals negative 1. And we do a quick check again, which gives us the absolute value of 2 times 4 minus 3. We want to see if that's equal to 5. So we get the absolute value of 8 minus 3. We're checking, is that equal to 5? The absolute value of 8 minus 3 is equal to the absolute value of 5, which means this did check out. And now checking -1, we have the absolute value of 2 times -1 minus 3 equals 5, which gives us the absolute value of -2 minus 3. -2 minus 3 is -5, which means it checks out again. So x equals -1 and 4 are both solutions to this equation.